Welcome to Maths for All. I'm Aisling Flynn. This is Statistics 1.6, Standard Deviation. Standard Deviation. Another way to describe the spread of data values is to look at the standard deviation sigma. So sigma is the letter used. Okay, the word deviation means how far away from center are the values. The standard deviation is an average of all the distances of all the data points from the mean. Okay, so the mean is used as a center, and the distance of each data point, if it's below or above, is recorded, and an average of all those distances from the mean is taken, and that's the standard deviation. So here's an example. Here we have 3 histograms for IQ test components. Okay, the first one is verbal for IQ, verbal IQ, and you'll see here the standard deviation is quoted as being 7.9. You'll see that most of the data is bunched quite closely together between 80 and 120 mostly. Okay, so the histogram is quite narrow and the peak is quite high because they're all bunched in there. Okay, and here we have a small standard deviation. The data is close together and many are close to the mean. The mean would occur somewhere in the middle here. Okay, so this would be where the mean is, X bar. Alright, if we look to the second histogram, you'll see that it's a little bit wider spread. Okay, from about 50 up to maybe 150. Generally, the standard deviation is quoted as being 15.8. That means that if you take the mean in the center, whatever that's 100, roughly, okay, that on average all the pieces of data are 15.8 below it or above it. Of course, some will be much closer and some will be much further away, but the standard deviation is an average of that. Okay, that's a medium standard deviation. The data is not so close together. And the third example is for spatial IQ, and we can see that there's a large standard deviation, that the spread here goes from perhaps 20 up to about 180, so much wider, and as a result the peak is much lower because they're spread out further. The data is spread out and there are many values from the mean, and standard deviation is given here as 31.6. So the standard deviation is a measure of spread. Now, to calculate the standard deviation, so we're going to go through the steps first. We're going to do an example manually, meaning using pen and paper and a calculator step by step, and later I'll show you how to do it all at once on a calculator. Okay, so to get the standard deviation, what you must do is you must get the difference of each individual data point, which is x, from the mean, which is given the letter mu. Okay, so that would be step 1, so to calculate the mean. Okay, and then to get the differences would be the second step. Okay, so x represents our variables, or each data, each piece of data. And this letter is Greek letter mu, okay, and it refers to the mean. Okay, so to get the difference means that you subtract. Okay, now some will be below the mean, meaning you get a negative answer, and some will be above the mean, giving you a positive answer. We're not interested in positive and negatives, just how far are they away from the mean. So what we do with all those values is to convert all of these to absolute values. We take the positive magnitude only. Okay, so we are only interested in positives. How far are they from the mean? And mathematically, to do that, what we do is we square the difference. Okay, squaring something automatically makes it positive because anything times itself will be positive, and then we'll undo that squaring by square rooting it, and we'll have the positive value. What remains then to do is to get an average of all these differences, that means we'll add them all together and divide by how many. So how many is given letter N. And this is what we have here. So to add them all means to sum or to add them together, plus, and this Greek letter here, which is capital sigma, tells me I should sum them. Okay, so sum all the differences that you've squared, divided by how many gives you the average, and get the square root to bring you back to just your value, okay, after you've squared it. I'm showing you it written like this because this is how the formula is presented in your formula and tables book. So if you don't want to memorize this process, you'll be able to go to your formula book and to read it and know what it means. Okay, and this will give you the standard deviation sigma. So here's the page in your formula book under statistics and probability. Okay, statistics and probability, you'll read down and you'll find standard deviation here. Okay, and we're getting the standard deviation this time of a list of n numbers. Okay, and here is our formula there. Okay, so hopefully now when we've practiced it, you'll be able to read that and understand and remember what you should do. Okay. So now let's give it a go. Find the standard deviation of the following numbers. So if you recall, our first step will be to find the mean. Okay, which is mu. Okay, so mu will be equal to, we'll have to add them all together and divide by how many. So how many? 1, 2, 3, 4, 5, 6. We'll be dividing by 6, and I'm going to use my calculator to add those 6 numbers. 12 plus 15 plus 11 plus 17 plus 18 plus another 12. Okay, and I get 85. Okay, now I'm going to divide 85 by 6, and that will give me the mean. So 14.16, now the 6 recurs, I'll round it off to 3 perhaps, 0.167. Okay, that's my mean. Alright, now I might create a bit of a table for the next bit, okay, because we have to repeat the process for all the values. So we have our x's. Okay, there are data points, our pieces of information, the ones we're working with. So there's 12, 15, 11, 17, 18 and 12. I could organize them if I wanted to, it doesn't matter. Now the next step was to find the difference, how far are they from the mean, and that was x minus mu. So x take away mu, and we'll call this d difference. Okay. So for each case, and bear with me, and you can try it on your calculator, I'm going to do x minus mu. So the first one, for example, I'll do 12 minus 14.167. Okay, and what I get here is minus 2.167. Okay, now I move on to the next one. 15 minus 14.167, and I get plus 0.833. Okay, so you see the 12 was negative because it's below the mean, and 15 was positive because it's above the mean. Okay, I'm just going to pause and work out the rest of them there. Okay, so the next values for the table are minus 3.167, 2.833, 3.833, and the last one is the same as the first one. Okay, now so there's the differences got. Now we said to counteract the plus and minus thing, we're going to square those differences. So we could, that's the bracket squared, or we'll call it d squared. Okay. Alright, so taking your calculator, if you multiply minus 2.167 by itself, what you'll get is 4.696. Okay, and so on. Alright, 0.833 multiplied by itself 0.833 by itself, you get 0.694. Okay, and you go do the same all down the table. Okay, so the rest of the values for this column are 10.030, 8.026, 14.691, and 4.696. Okay, so if you see the values that were furthest from the mean, for example 18, all right, give you the highest value here in this column. Okay, so the next step now is to get the average of those d squared. Okay, so basically we're getting, the mean of d squared. What does that mean? It means we have to add them all up and divide by how many. Okay, so I need to add all these values and divide by 6. Okay, so let's take a moment to do that on the calculator. Okay, so the total of those came to 42.833, and I have to divide that by 6. Okay, so dividing by 6 I get 7.139. Okay, now that's my average of the distances squared. Okay, or formula wise that would be x minus mu squared divided by n, and the sum of them, we've added them all together. Okay, and the last step now, the last step is to get the square root of that, all of that, because that was our formula. Okay, we've added them all together, all the differences that were squared, and we've divided them by 6 by how many. Okay, so we're going to get the square root of 7.139. Okay, square root of 7.139, and I get my sigma equals to, and again I'll round off, 2.672. Okay, and that is the standard deviation. It says on average the numbers are 2.672 away from the mean, which was 14.169, and you can see that's probably true. Numbers like 18 are nearly 4 away from it. Numbers like 15 are less than 1. 12s are 2 away from it, and so on. So that's the average, and that's your sigma. So if you need to rewind and watch that process from the start, go through the steps, follow the formula, do that. Okay, so that's how we do standard deviation manually by hand, step by step. Okay, now if the range of data is large, the standard deviation would be large, so if it's spread widely. However, one outlier would not change the standard deviation drastically, as it is but one value in the average. So that's why standard deviation would be better than using the range. Okay, so because you're getting averages. It could be very time consuming to calculate the standard deviation when there are many values. Okay, so imagine we only had 6 in the previous example. If we had 600, we wouldn't be doing it manually. However, luckily our scientific calculators are capable of calculating the standard deviation, and of course programs such as Excel, etc. would do that for you. Okay, so the next slide shows you how to do it on your calculator. So here's the Casio calculator, and this is how you do standard deviation on it. And here is the process printed out for you. Okay, we're using the same number of values, and here are the instructions for the Casio. Okay, so they're printed out here, but the video to the right goes through each of these, explaining each one. Okay, all right, have a look at this. So here's standard deviation on the calculator. So firstly, we need to select the correct mode. So here's the mode button, and I'm going to select number 2 for statistics from the menu above. Okay, so there's lots of options here. I'm studying just one variable, so the values that are recorded, that's one variable. So one variable has number 1 beside it, so we select number 1. Okay, and here appears a table. Now this frequency function, that's not always visible. Okay, in our next video, working with frequency tables, you'll see this, but we don't need it right now. So under X, we're going to enter our variables that we've to find the standard deviation for. So enter one by one. So 12, and press equals to enter, and you'll see that the calculator scrolls down. You'll see, just notice the frequency says 1. That's fine. We ignore that for now. Next variable was 15. The next piece of data was 11, 17, 18, and there was another 12. Now, all my data is entered. You can see there we've gone down as far as 6. There's 6 pieces of data entered, and they are stored now in the calculator. Okay. When you go to do it again, you'll just restore new values. Okay. Now we're going to press AC to come out of that screen. Okay, and you see it's blank, and we're in statistics mode. Okay, so now to study the data that you've put in, we're going to make use of this function down here. So if you look just above the number 1, you see stat for statistics, and it's in yellow writing. So that's what we're going to select now. Okay, so really mode is used for inputting data, and stats is used for studying the data down here. So shift and the number 1. And now we've a selection to choose from. We are going to choose number 4 is for variance. How are our values varying? Okay, so number 4. And now we have another menu, 1 to 4. Number 2 here, X bar, that refers to the mean. So if you wanted the mean, you could press 2 equals, and gives you the mean. But we don't want that. So let's AC again, shift stat. Variance, we want sigma, we want the standard deviation, which is number 3, sigma x. Okay, so select 3 and press equals, and that is your standard deviation for this set of data. Okay, so you see you get the same result. You get your sigma equals 2.672 as we got manually. Okay, but far easier, far quicker. You would have to go through that process a good number of times, but then I think you'd find that you'd remember it. Okay, now time for you to try it, do your quiz and the written exercises.